It's a lightning talks moment, and it's basically the reason I organized the whole conference, because
So don't fuck it up, okay?
No. I love lightning talks. So how does this work? So volunteers, brave, thoughtful people have volunteered to talk for 5 minutes on a topic of their choice. I will ask them to come on stage one by one. And if there is a presentation, there might be a little bit of setup. And then we'll start the timer, and I didn't say it before, but the 5-minute clock is something that is really strict, and we'll do it like this. So I will give a 1-minute warning to the speaker. So first, thank you for everyone who has volunteered for lightning talks, especially the first brave Fabio who put the first name in the thing. So I will give... I will give a 1-minute warning to the speaker, and then what I will do? When we start 15 seconds from the end of the 5-minute counters, okay, some speaker can also end before the 5 minutes and all is well, we all will start very slowly clapping, and I will tell you 5, 4, 3, 2, 1, and then when we reach the 5 minutes, the clapping will be something that the speaker will have to stop. Okay, this is how it works and how it's done and how we will do it. So first we will try this 15 seconds of slowly clapping and going to the extreme just to start.
Thank you.
Okay. I will not have the microphone. And okay, so you just look like this. Thank you very much. Okay. So.
Tell me when.
Yes.
Okay.
I think we're ready, and the first speaker is Fabio Lipreri, who will talk about property-based testing.
Thank you. So, how many of you know about property-based testing? Not so much people. Cool. So let's explain it with an example. This is a function that computes greater common divisor. Use the Euclid algorithm, doesn't matter how it does. This function have a bug. Can someone spot it? No, we have not too much time, so later. So this is a classical unit test. So unit test has 3 main parts. Arrange some input and some expected result. Act, so call the function under testing with the input parameter and have a result, and assert then that the result is equal the expected result. So in this case, 15 and 6, the greater common divisor is 3, 15 and 5 is 5, and so on. So the code of before, the GCD have a bug. I run this test. 2 passed. Why 2? Because I don't know, the demo was broken. It's just one test pass, and we are very happy that our code works. Let's change the perspective on how we test. So let's forget for a moment the arrange phase. So we say that we have n and m that are passed from someone, and we call this function GCD. So this technique is called property-based testing. So the property word is very important. What we can say about property of GCD? What must the mathematical property in this case, because is a mathematical function, should be always positive, should divide n and m by definition, and no other number bigger than d should divide n and m, right? This property should be true for every couple of input, because our property of the GCD function, of the GCD input output. So some of you maybe start to understanding the principle of property-based testing. We don't need anymore some fixed input. That is what we need when we do classical unit testing. Because in classical unit testing, we must define input. But we are human, and we can think about all possible input, but we can't cover all the domain. With property-based testing, we fixed the property of the function, and now we can throw whatever we want to the function, because these properties are always true, if the GCD is correct, of course. So now I talk a little bit about hypothesis. Hypothesis is a Python library, but you can find a library for do property-based testing in any language, but we are at Py4AI, so Py4AI. This hypothesis gives some function to throw to your function the input that you want. Here, for example, I'm throwing 2 integers, because it's what my function expects. One integer from 1 to 100, and another from minus 500 to 500. It's just an example. You can define whatever type of complex variable you want. Go to the documentation of hypothesis. It's very rich. So what is happening? Hypotheses generate a lot of input sample, like 1,000, million, maybe not, but 1,000 of sample. Throw it to your function, and our property should be always true. Whatever we throw to the function. I run this, and it doesn't pass anymore. Say that there is a zero division error. We forgot to check in the first function that n should be not 0, because we can do the division. With my first, of course, this is a very simple example. Think about a more complex example. I forgot to put this input as a test input. I not covered all the domain. Hypothesis helped me to cover all possible input. And yeah, this is the cringed girl. So, property testing, the definition is that we should make properties that are always true regardless of what we throw to the function. Thank you.
You and also you. Okay. Next, we have Zainab Nazare, who will talk about Parkinson's disease diagnosis with machine learning.
Thank you.
You have to stand here, and she will not be using the round. Okay.
Hello, everybody. My name is Zainab, and I'm going to talk to you about Parkinson's disease. Probably you have heard Parkinson's disease is a loss of some neurons which are generating dopamine in the central part of our brain. And this disease is going to increase as population is aging. And we know, like, globally is population aging, and the incidence of this disease is increasing. The problem is that this disease is diagnosed usually quite late, like when 30 or 50% of your neurons are already dead. People learn some motor symptom, the symptom that is affecting like the movement and other things quite late. So our purpose is to diagnose this disease early. And for that, we have like some glossary of data, and one of these important data that I am working is RNA sequence data. So what is RNA sequence data is like quantitatively having data for your genome in your body, and then we apply machine learning in order to understand like how they are different from a person who has Parkinson and the person who doesn't have Parkinson. And this way you can somehow regulate and help to diagnose, and also check the progress of the disease over time, because there are some repositories that they're collecting data. One of the famous one is PPMI. And this is founded by someone who was the actor, Hollywood actor, and got Parkinson at the age of around 30, and then founded this like big repository and this research focused on the Parkinson disease. And they have data for people who have Parkinson, people who have like in between, and people who have like they are healthy, they're not showing symptoms. So for scientists to be able to do some research for the early diagnosis of this disease. And each of these there are grocery of data, so it's not just RNA sequence data. They are collecting data from clinical self-assessment and also images to have a combination of the information about the disease. And it's very important to have all this data because each of these data, they have their own power. They have their own way of diagnosing the disease and helping us to understand it more. The fact that we would like to join the data. I'm also working on RNA sequence data, and we already had some good result of having some AUC improved, and we have a quite good distinguish between the people who have Parkinson or not. And there are also other neurodegenerative diseases that we would like to know earlier to understand, like with this RNA sequence data, we can understand more about it, and particularly because this RNA sequence is taken from the blood and it's not invasive. There are some other data that are invasive. Like for instance, we have proteomics that in order to get the data, and it's like in the back of the patient and it takes a day maybe in hospital to take, but it's close to brain. But still blood is non-invasive and could give us a lot of information about the patient. Thank you.
Thank you very much. Thank you very much, Zainab. Okay? Yep. Okay, we can go with the next one. So, Andrea, you weren't ready, but you are ready always, right? This can happen. I mean, Lightning Talks is ready for everything. And in the meantime, well, we last talk also had. You want to have 1 minute left to say something? Okay. Yeah. Oh no, Lightning Talks. Did I tell you that on the blog post? Are we ready? Okay. I'll take it for the next break. This is like that. So, Andrea Guzzo will tell us about why science is broken, yes, and also about the origin of Py4AI. No, we'll see.
Science is broken.
Okay. Okay. I give you. Okay.
Okay.
We forgive you.
Ciao, guys. Ciao. So, I'm Andrea Guzzo. I was working in MDPI, one of the largest publishers in the world for open access, and I was the technical leader for AI. And basically, I'm here to talk about a little bit about why science is broken. And guys, science is broken. Like, it's true. But why? So this is a picture. Do you think it's a joke? But actually, it's a picture that was released on a scientific publication. I don't want to say why. And so basically, it's generated by an LLM, of course, by a model. And there are different ways why science is broken. So we have now in science like paper generation problems. So there are people that are generating papers, informations. Peer review comment generation. You can imagine what can happen, and it's a real problem. Image generation and manipulation. You can see here a real concrete example. But also, there are other challenges right now because the number of applications are increasing a lot. So for example, there are a lot of problems in literature review. If there are a lot of contexts that are generated, how can I find my important information that I have to search? And of course, what is novelty now? If everything is generated and these models are, I don't know, copy and paste, it's not like that, but okay, it's supposing that they are copy and paste something, okay, based on the input data. What is novelty now in science? What does it mean discovery anymore? So basically what is happening is that we are moving from research, publication, reality. This is the science, okay, what science is doing. Imagine the COVID, no? Imagine if I publish something related to COVID that is generated by an LLM. Imagine the impact in the world. And what is happening now, and thank you for the previous speech, by the way, a lot of data that are generated are used now for looking for what is reality, and also are used also for new generation algorithm again. So it's an over and over loop that continues forever. We have some regulations. OpenAI said, oh, okay, guys, we have a super huge model, super great, that is called ChatGPT, but unfortunately, we cannot create classification algorithm that says what is wrong and what is right. Okay, so what do we do? Like, okay, so what can we do? If I generate something, if I generate a paper, I cannot say what is good or what is right or what is wrong. Where are we going? And this is a problem. And basically, they claim that, unfortunately, they were not able to create a classifier for the all data they can generate. Thank you. So we have to fix science, guys, really. It's a huge problem, and we have to find a way to develop new detection system to detect if an image is generated or not, manipulated also, not only generated. There is a problem of watermarking. There are no watermarks in the models, and this is a real problem. Regulations. Right now, at the moment, COPE, it's basically the official agency that is behind these regulations in science, is saying that AI tools cannot meet the requirements for authorship as they cannot take responsibility for the submitted work. As non-legal entities, they cannot assert the presence or absence of conflicts of interest, nor manage copyright and license agreements. So what we do, really, like, is happening. Like, we are seeing a lot of papers now published. For example, this is an example cited by Andrea Palladino in the first talk about the problems here. So you can see like a text generated inside a paper. It's a really like huge journal, this one. And basically, we don't have regulations. We don't have models that are able to detect if something goes wrong or something is good or not. So I'm here to say we have a problem, and we have to try to solve this problem, guys, really. Really. That's it.
Thank you. So, while Tim comes on stage and puts up the slides, you can tell us why we have Py4AI.
Oh. Because actually, I'm from Biella, and we had a really great, I would say, event in Biella, talking together with some of the guys from Python Milano, because we like to do things each other, you know. And we were eating polenta, probably someone knows. And at the end of the story, we end up here in this beautiful location. And thank you so much, guys, for organizing this, because it's so great to see you. A lot of people from AI here talking about this stuff. It's so great. Thank you, guys.
Thank you, Andrea, for being part of the origin story. So, next is Tim Bonneman. I mean, Andrea told us that how to decelerate science with AI, but Tim Bonneman will tell us how to accelerate science with open source.
Awesome. All right, hi guys. So I'm here to talk about open source science. My name is Tim Bonneman. I work for IBM Research. I do community there, and my main focus is on this initiative. It was launched in the summer of 2022. It belongs to NumFocus, just like the PyData conferences and the PyData meetups. And the idea is to accelerate scientific research by improving the open source infrastructure for scientists. So we connect scientists, open source developers, other stakeholders to share best practices, to infuse the open source ethos into the scientific process, to identify pain points, and then hopefully also come up with solutions. IBM had the idea. They planted it under NumFocus intentionally. There's some money and some resources from IBM to support this for the first couple of years. And for some of you I've talked to already who are in science, you may realize that there's some issues. So what are we trying to do? The idea is that we need lots of science going forward. We're facing some pressing issues as a planet, as a humanity, particularly in fields like chemistry and climate and healthcare. And increasingly in these fields, the scientists have to rely on the most advanced software and AI. And a big piece of the puzzle there is open source. But the overall ecosystem is very immature. So you may have experienced that you publish a paper and the code that you develop goes into the trash. You may have experienced that there is no system to sustain the software that you develop. You may have gotten penalized for spending too much time as a scientist on developing good open source when you should, your boss tells you to publish more papers. Yeah, okay. And so lots of interesting, quirky challenges. There's also a skill issue. Not every scientist is the natural-born software engineer, right? And so we're trying to come up with ways to support scientists. So this is how this initiative was born. We work in interest groups. We have some domain-specific ones with more to be added this year. We also have some horizontal ones that go cross-domain, including a group that is working on building a map of science, allowing you as a scientist to see which open source tools are available in your domain and also see how they have been used in published research. We're working on getting some funding to actually build this. You can join the community. Everything's open. You can join our calls. You can see what we've shared in terms of notes. And talk to me if you want to learn more. And I wanted to show just one thing. So this has taken a bit longer, but the interest groups are finally starting to produce, hopefully, useful output. So this is something that was presented last week. Sorry, this is small. So in the chemistry group, they're building a collection of tools for reaction prediction. Oh, I can. Right? So imagine, this is still a very small list. This is like a nucleus. But imagine a few months from now if someone who's interested in reaction prediction could find this resource and just see all the vetted tools that a community of scientists has already spent a significant amount of time on to evaluate, to find bugs and all that stuff. So then you, as the, let's say, 101st scientist, after 100 have already worked on it, could just start with a head. And in the process, we accelerate scientific research, right? So that's just one example. We're hopefully going to have many more of these. There's another project on collecting foundation models for chemistry. The life sciences group is starting their own kind of small lists. And so, we hope if you're in science or if you're science adjacent, right? If you like science, if you know people who are doing science with open source, talk to us. We'd love to connect and find ways we can help you and serve you. So thank you very much.
Thank you, Tim. Luca is on stage now. Okay, so I was telling you before that we have a blog post on the website in which we announced the lightning talks, and there are a couple of links to YouTube videos that contain lightning talks, and I've selected 2 of them which are particularly funny, and then you can go on and watch the rest. If you are enjoying lightning talks, I mean, it's not that everybody has to enjoy lightning talks. Okay, are we ready? Okay, so now Luca Baggi will talk about Marimo, the better Jupyter notebook. Thank you, Luca.
Ciao ragazzi. There you go. So most of you know, or most of you should know me by now. I work as an extremer by day and by night an open source contributor. So I found out about this wonderful project called Marimo because I can also be a bit opinionated. Does anybody see this sticker? Yeah, I think most of you should know the library I'm pointing at, Polders, okay? I have this kind of obsession with Jupyter notebooks too. I was working with Fabio on a workshop we're going to deliver in a couple of weeks in Lausanne, and he put a notebook in the repository. We agreed about that, okay, so it's okay, I'm not blaming him. But the point is, even though GitHub allows rendering Jupyter notebooks, they're really hard to work with. You see, I'm trying to do a review of the pull request because we're engineers, right? We do pull reviews, but I cannot edit, I cannot add comments where I would originally be able to do that if it was just plain code. You see here, if I can select these rows, I swear you can just do one as I did kinda about below here. You can do that with notebooks. They're a mess to work with, okay? And when I found out about this small project on trending on Hacker News, I was like, I should give it a shot. And it's called Marimo. And it's a notebook, you see. And this is very small, so I can make it a bit bigger for you. And maybe I can hide the Tmax pane. Maybe it's not. This is not the point. You install it with pip install Marimo. But since I'm also opinionated on packaging in Python, I'm using PDM, okay? It's okay. Who uses PDM here? Oh, okay. Okay, no, that's depressing, but it's okay. So I just run Marimo edit notebook, and the notebook pops up. And you see here that it breaks immediately, but that's because I made an error in the code. And you see here, what's it doing? It's just running whole dependent cells on this one. Because notebooks in Marimo are reactive, and every cell is basically a piece of a DAG, of an acyclic graph. So you can have cells rerun automatically when you change the content of one cell, which is a pain when you do it directly with notebooks in Python. And you see here that it's running and it's rendering. And also, think of it, this is a dashboard just to explain MNIST dataset, but here I have a cluster analysis. It has a sick UI, by the way. And you see here that it's already using compute embeddings. I haven't imported any library here. And if you go below, all the import code is below. So this makes it wonderful to create entertaining storytelling and sharing content with others. But the best thing about Marimo is not only this one, is that if you look at the code, which I have here, is plain Python. The structure isn't like plain Markdown, but you see that basically what Marimo does is creating cells using Python syntax. Every cell is represented as a function, and every cell is added using a decorator to the app itself. So basically you can rebuild this DAG from your code so that you can version your code as plain Python files, do proper code reviews, don't have to worry about putting the notebook and stripping the outputs because everything is just JSON, okay? And the beauty of it is that you can edit as if you were using, I don't know, an editor. No, I'm not using VS Code, I'm using Vim. So, okay, that's a bit of a cliche, but it's a pleasure to work with because I can spin it, I can just open the Python file. I don't have to think of a server, I don't have to run a server, the process, and opening on some connection on the browser, etc., etc. I can just come here and edit the stuff that I need. And this makes it wonderful, but also you can run it as here. And so if you see here, I'm not using edit.py, I'm not edit the notebook.py, I'm just saying run nb.py, and basically like a Streamlit app, it opens up as an application, which can be interactive. So you can select here, and a bunch of things will happen here. You can edit the data, and everything else will be recomputed on the fly. It also has UI elements, a really nice view for dataset, and you can use all kind of crazy stuff here with Notebook. The most interesting one being, let me do this. Wow, this is a live coding hardcore experience. If you go to, thank you, wonderful assistant. If you go to marimo.new, you get a WASM-powered notebook, which runs in the browser. So you don't need to, you can install some libraries, but it's all on the web, and you do not have to pip install it. It runs here. Go check that out. Marimo is awesome.
Thank you, Luca, for reaching the quota of opinions at the conference. I think you in 5 minutes, so many opinions, and also for helping raising the content of Python. It's over, Luca, go away. Yes, come in on stage, please. Get rid of us, of Luca. We can't have it anymore. You do not have slides. Okay, perfect. So we can start right away. Matteo Mortari will tell us about how to contribute to Kubeflow, which is Google Summer of Code 2.
And also Google Summer of Code. So, hi everyone. Ciao, my name is Matteo. I'm an open source enthusiast. I also heard that there are other open source enthusiasts in the room earlier this morning and today. So I really want to speak to you about Kubeflow project, a project that I recently started to contribute, because there I can see opportunities really to contribute in open source. So I will come back to that just at the end of the 4 minutes that I have here today. Just to know ourselves a little bit better, pardon me, I'm very new Pythonista. I've been working 10 years in Java, so help me get a better understanding of the room. How many are familiar with Kubernetes here in the room? Can I have a show of hands? Okay, not so many, but how many are familiar with MLOps platforms? I guess that somebody, okay. So we have to deal, I guess, with data scientists or software engineers with these kind of things. I will just give you an example on how does it matter. So this morning, the talk of Gabriele, one thing that stuck with me is what made enable this generative AI and these larger language model, these machine learning models nowadays, the availability of data and the availability of hardware, specialized hardware. So when I hear that, I think about, for me, what it means as a software engineer is cloud infrastructure, cloud workloads, where our application nowadays run, then it's like if I try to connect the dots this morning with Merve, we've seen, there are a lot of availability of new machine learning models on Hugging Face. So we can experiment with that, we can check. So let's say that now I'm working in my company that maybe have some regulation requirements, some compliance requirement on how do I run the things in my Jupyter notebook. I heard, sorry for I'm not using the other notebook, but I will check it out. So let's say that I'm limited maybe by my laptop hardware, but the company provides with me the availability to run it in our cloud infrastructure. That is where Kubeflow starts to help, because as well you can have these machine learning models. You will do the training, the experimentation on your cloud infrastructure available. And then you can also provide them with a data science pipeline. So you continuously train the model with the new data that will coming in. You may as well harness the power of scalability that your company made available server can provide to you. So I really wish that I could have the 200 and more GPUs of NVIDIA in my own private cluster. So maybe at night I can try to use it for gaming, but that is not realistically possible, right? So I can make use of that for have distributed training. And as well, finally, what is the result here is that we will have our machine learning models and our fellow devs will need to connect their own application that will be made with Flask, Fast API, whatever is trendy with the frameworks in Python or your language of choice needs to connect to that. So this is where you connect really all the dots. And Kubeflow is such a toolkit. It's a toolkit that makes that possible on Kubernetes. And it's like maybe you'll go back to the company tomorrow, and if you hear Kubernetes, then you can say, oh, yes, I've heard also as well about some frameworks, some toolkits that I can make use for it. Why I think it matters is that it, like Kubernetes, it works with hyperscalers. So if you use AWS, if you use Azure, if you use Google, it doesn't matter. It works on a hyperscaler, on-premise. Maybe you have, for compliance and regulation, your own server, your own cloud infrastructure, or on hybrid setup. Now, I was mentioning that I'm an open source enthusiast. So I just want you to know that as Kubeflow, there is an entity created for the Google Summer of Code. That is a program that Google makes available for students or people who are unfamiliar with contributing with the open source project. And what you get out of it is that you have some mentoring opportunity, there is some monetary contribution, but the experience in getting started with contributing with open source, it will be invaluable for you as an experience, but also as well, of course, spending it as a skill on the job. And so in 10 years, I think as a software engineer, I've heard, how do I get started with open source? There are many ways, but with this opportunity, I think that you have a lot of opportunities available, and it makes it a lot easier with mentors available to you. So I invite you to check out kubeflow.org. That is KUBEFLOW.org. And in the case, I'm here for the rest of the conference. Thank you.
Great. Thank you, Matteo. Thank you, Matteo. So who's next? We have Marco next.
He hid himself.
He hid himself. He doesn't want to do the lightning talk. And you need the presentation. Okay. As you've seen, I mean, lightning talks are also, you want to talk about something, just go and do it. And that's great. There are... Just do it. Oh, no, okay, no, I can just... Okay, you can start? I start the clock, Marco? Be careful. Be careful. I can do it, Okay. No, it's one of the way that you have variety, that you have community, variety. We haven't talked about diversity, which is one of the core values of PyData, which is something that we care a lot about. Okay, Marco Santoni is unverified, and you are on stage.
Okay, thanks. So, you are stealing my time, please. Let's make a quick survey. Where do you develop code? Raise your hand if you develop on a Mac. Okay. What about Windows? Okay, more or less the same. Linux? A lot. Motorola? No one? Then you are not a Gen Z. Because with the Motorola, you can develop when you're on the bus, when you're at the restaurant, you can develop when you're at the toilet. So today, for the first time in the history of a Python conference, we will do a live demo of coding with a Motorola. Actually, we will not do just a Python code, but we will run a Apache Spark cluster to process a big data set. Okay?
You need me to do this?
So, so if you are a Gen Z like me, then you can... So I'm streaming my mobile via Microsoft Teams. Thanks, Microsoft. Okay, then a Gen Z just need a browser, okay? Then you launch your favorite cloud provider. For me, it's Azure, of course. And I launch a Databricks workspace. That's a non-production workspace, okay? So our boss doesn't need to know anything. So to launch a Apache Spark cluster, it's just easy. You just tap with your finger on this small button on the left called SQL Warehouse. It's very straightforward developer experience. Then you click on this button, create a SQL Warehouse, give it a name, like this one, Py4AI. You select the size, something small. I mean,
it's not cheap to be a Gen Z.
Yeah, I mean, I don't care. My boss will never know about this. With two nodes on the cluster, so that's really parallel computing, and we tap on create, okay? So now we've just created, in a few seconds, an Apache Spark cluster.
How does it work with passwords?
So let's open a SQL editor. Everything is very safe and secure.
Okay.
Then you scroll to the right, you tap on the plus here, and tap create new query. I mean, it's a bit hidden, but tap, okay. Then we can write in plain SQL a PySpark job. Then we select the cluster that we have just created here. It's called Py4AI. It's already turned on, super fast. Then, it's too much zoom.
It's tough to be Gen Z.
Then you select the database or whatever, the schema, blah, blah, blah. Okay, and then you write with your favorite language the query. So we'll make a select, count, star.
I see you sweating.
From space, then the schema name, let's do this one, flowy, and the other one, up, I hope, okay. This is the table, okay, self-suggestion works smoothly on a mobile, you can see. Then you zoom out a little bit, my wife is she's watching. She's watching, and then you just press the start. And now, when I press start, I will run a distributed big data query on cloud. Tap. Let's wait. It's executing. You see at the bottom. Yeah, and that's it. So, when I graduated 10 years ago, it was 2014, I've done some training on big data, and I had to study HDFS, Cloudera, Spark, even Java MapReduce. Again, Java MapReduce. And now, this is it. So, my message for today is, if you think AI is too hard, just wait 10 years. Like I will do, and I will be safe. That's it.
Who said Riccardo? Okay. Thank you, Marco. The title was Big Data Like a Gen Z. Sorry for missing that part over there. Yeah, this is really lightning talks for people who like to live dangerously. And also now I understand what you were doing in the alignment call of the conferences. You were doing Spark. Where is Marco? Marco, are you doing this? No, you were launching Spark jobs on your phone. Okay. So, lightning talks. All different kind of lightning talks. By the way, the people who have done lightning talks have done a present to you. Do a present to them and go talk to them if their lightning talks interested you. Because one of the reasons you do lightning talks is also to connect more with people, and this is one of the theme of today. Connecting video equipment, connecting people, connectionist AI with neural networks, connection in other different ways. And connection does not always work, but we are a community because we are able to do it. So, without further ado, Riccardo Musmeci will tell us how to unleash your Mac with MLX.
Okay.
Take it on.
Hi guys, so I'm a computer vision engineer in a big company that pays me the GPUs, but in real life I don't have GPUs, like big GPUs on my Mac. I still have, an M1 Pro, whatever, Mac, which has a great GPU, which is not the fancy one, but still it works. And I was trying to be able to run like LLMs and stuff just for fun on my computer. But before this date here, which is December the 6th, we just had PyTorch working in my Mac. So, but then the Apple ML research team came up with this stuff, which is PyTorch optimized for Apple silicon chips. From that day, I started playing with LLMs first, because I wanted to play locally and in real time on my computer, because it's 3K of computer, so it must work. And since then, I started playing with this ecosystem. And one of my first applications was running multiple, or at least trying to run, building the code to run LLMs on my computer. So today I'm showing you like the first, a little bit, yeah. Okay. The first project I started, no, it's okay, sorry. The first project I started in December, like after a few days, they released the code, which is running a chat with an open source LLM. Which is a 7 billion model, but I think it's great to use too. And now giving a little bit of time because my computer is kind of, let's say, hold right now. Just give me a second. So right now we are playing with Dwight Kate Schrute from The Office with an open Hermes 2.5 Mistral 7 billion model, which is a great model. And now we're gonna ask him something like, who's your enemy? Now, give you a little bit of time, but right now, so the model is running on my GPU, and now it will start like producing words, of course. And since this application, I started using this framework a lot. Give you time because also there is this kind of stuff. But I also built like a RAG on my computer, doing everything from scratch because I like doing open source stuff, and why not? And since then, like last week, I worked with Merv there, with the Hugging Face team for another project, which is called MLX Image, which is a pip installable package for your Mac. And the idea is to have like a team that they have in their system, in their company, but for Mac. So it runs like models converted for these kind of machines. And right now what I'm doing is converting models to this framework here, which is very similar to PyTorch, but there are some differences, which is a very pain in the you know what. But still, yesterday or 2 days ago, we released this documentation on the hub on how to use the library, which is very PyTorch. I mean, it looks like PyTorch because I built something really similar to PyTorch because I don't want to learn another framework from scratch. So I built something very, very similar because I'm lazy. So that's why. But right now you can use up to 16 models that were, let's say, from my spare time. So my girlfriend is not happy, but I mean, I love coding. And let's say from a couple of weeks ago, I started working on this library on my spare time. I'm planning to add more and more models like Zwin transformers that some of you mentioned today. And I'm going to do like a PR in the next days. And I want to build more on with this project. And of course, it's open source. So if everybody wants to contribute, we also have a space on MLX, on Hugging Face, in which you can upload your own weights. So yeah, that's basically it. So that's why I try to unleash the power of this machine with MLX. And so yeah, that's it.
Thank you, Riccardo. Since I'm not able to keep Luca off the stage, I think I will ask him to introduce myself.
Just, okay.
But you have to say something.
Okay, something. Was it a Beatles song? Okay, so jokes aside, while Pietro gets ready, I would say to give him a round of applause. A big one. Just to put up the expectations. But, so Pietro was already in the Python Milano community. And when he went last September in Amsterdam, and we attended PyData Amsterdam, which is like one of the biggest PyData conferences in Europe, he came back and he was super excited to bring PyData Milan and create PyData Milan chapter. And he did an amazing job to gather people, find the energy, the time, the motivation to connect with the PyData and NumFocus and ask them how to put us in touch together. So,
doing another lightning talk?
Oh yes, exactly. It was about your origin story. So, so it has done an amazing job for Python Milan and for the Python community in Milan, but also say in Italy, because we also here, and so many people did an amazing job, but Pietro gave us the boost. So I'm really welcome to have you talk give this amazing lightning talk, which is AI, a blast from the past.
Thank you, Luca. I have 5 minutes, and I thought I could fit a short history of AI, since AI just really started with ChatGPT less than 16 months ago. I actually found out there is more to it, so here is a very compressed history of AI. Compression fits very well AI. After all, ChatGPT is just a big zip file, right? So, in Anno Domini 60, hero of Alexandria... Oh, this is not working as I hoped. Haha, this will be a problem. Okay, let me try it like this. Okay. So, I will go faster. Yeah, but, no. So, in Anno Domini 60, hero of Alexandria created what might have been the world's first practical programmable machine, an automatic theater. And I find it fascinating that the first historical record of AI, according to Schmidt-Huber, and who am I to contradict the guy, is about a form of art that stubbornly refuses to die. But AI seems to be coming for all artists, after all. And it will be really... I will not get to the end of the slides, but it's fine. Oh, okay. Around 1580, Rabbi Judah Loew ben Bezalel of Prague creates the golem. Animated by truth, but lacking free will, a golem always does exactly what is told. The golem is incredibly powerful, but its obedience also brings danger. And I think it's not time yet to retire this foundational myth of AI and science fiction. And let's see if I'm able to. In 1770, Wolfgang von Kempelent built the Mechanical Turk, a chess-playing machine that was revealed only 80 years later to be a hoax. I guess there is a lesson against closed source AI hidden somewhere inside the Mechanical Turk. In 1843, Ada Lovelace, in the same set of notes where she published the first program of history for a machine that would never be built, makes the following remark. The analytical engine has no pretensions whatsoever to originate anything. It can do whatever we know how to order it to perform. It can follow analysis, but it has no power of anticipating any analytical relations or truth. It is rather well known that the first appearance of a neural model was in an article by McCallum and Pitts in 1943. I don't know what's looking at this. It is less well known that the same article stimulated an analysis by mathematician Stephen Kleine, which introduced a tool used by every developer, regular expressions. In 1961, Donald Olmici designed and built Matchbox Educable Knots and Crosses engine, Menace, a mechanical computer made of 304 matchboxes that can learn how to play tic-tac-toe. Roughly 40 years later, I read about Menace in an Italian crossword weekly magazine, and it's still the best image I have in mind of what reinforcement learning is about. Look it up, it's worth it. Around 1966, Joseph Weizenbaum created ELIZA, a chatbot that was able to simulate a psychotherapist of the Rogerian school. The technology used is mainly pattern matching using regular expression. Weizenbaum said at the time, "What I had not realized is that extremely short exposures to a relatively simple computer program could induce powerful delusional thinking in quite normal people." I'm getting faster at this. In 1969, Marvin Minsky and Seymour Papert published the book Perceptrons. The book contains a number of mathematical proofs that emphasized limitations of neural nets-based approach to AI, and was influential in concentrating research efforts towards the symbolic approach. In 1979, Hans Moravec was able to make the Stanford cart cross a room filled with chairs without human intervention in about 5 hours. He later phrased what is now known as Moravec's paradox. It is comparatively easy to make computers exhibit adult-level performance on intelligent tests or playing checkers, and difficult or impossible to give them the skills of a 1-year-old when it comes to perception and mobility. Whoa. And in 1996, Ismes, later acquired by Chesy, develops Mistral, an expert system that is still used in dams all over the world to monitor their safety. Expert systems were the first truly successful AI technology that, starting in the 70s, generated excitement and big investments, until they didn't anymore. Thank you for your time.